Okay, so far we in our last lecture series, lecture 4, we looked at functions, how to use built-in functions, and also we went on to look at how to create our own functions, which we can use for specific things, called user-defined functions and lambda functions. Now, it so happens that for you to really get the best use of functions, once you create a function, you need to store them somewhere. And that's where modules come in. So basically, these are text files you create where you store functions. So you create a function, then you store it somewhere. And basically what people do is they collect all the functions which do something specific. So if you've got functions you use for a specific thing, you collect them, then you put them in a file, then you give that particular file an appropriate name, and that's what becomes a module, and that's basically what I want to look at today. So once you have this module, assuming that you have this module, of course Python itself comes with these modules, a lot of them, and you can also create your own modules. So what we want to look at is how are you going to bring the functions which are in this particular file in the current programming workspace so that your Python can actually start using these functions. How do you import them? That's basically what that's a process called importing. So we're going to look at how to import an entire module. Sometimes you're not interested in importing everything. Sometimes you're simply interested in importing some variables and also functions which are in that particular module. So a module, as I'm going to show you, can actually contain variables. In physics, we have got all these different constants we use. As I'm going to show, I've created a sample module which contains constants, which you can use, and we want to see how we can do that. The other thing we can do is that sometimes maybe the name of the function or the name of the variable is too long. So you want to find a short word you can use, or a nickname. That's what's called an alias. So we want to see how you can import a specific function using an alias, and also maybe the name of a module, the file itself is too long, but you want to find something short you can use. So we're going to see how to import an entire module using an alias. And then last but not least, though not encouraged, you want to import everything at the same time. You can do that, but it's not very encouraged. We'll show how to do that. Of much use to us, of course, is the fact that Python comes with the ability to allow you to create your own modules, which are these files. So depending on our fields of physics, whether it's atomic physics or whatever kind of physics you're doing, if there is formulas which you use regularly, those formulas you can translate them into functions and you can store them on files so that you can start using them. So let's start with the definition of what a module is. So basically, a module allows you to store variables or constants and also functions in a file, and these files usually end with .py. The funny thing is most files in Python end with .py. So if you look at
three letter,
sorry,
it's always py.
Just py. It's always py. All Python files, your program file ends with .py. Your module files end with .py. As we are going to see also, even classes they end with .py. So once you have created your variables and functions, you can use these as much as you want later on, or once you have created a module which is useful, you can actually share it with other people so that they don't have to go through the same process you went through. So basically, it's a way also of saving time and also sharing whatever you have done. Okay. So basically that's why modules are important. Here I've got a list of some of the modules, Python modules, which already come with Python and third-party modules which people have created. So basically, one of my tasks that I have is to try to populate this table with as many modules as possible, as many names as possible, so that people don't have to necessarily have to go on the internet. You can just look at this, then also provide a classification later on for different purposes, what kind of modules you can use, so that it's easier for people to get started. So basically, that's what this table is about. So far, this is how much I've populated, but it still needs to be filled in. So that's basically that part there. Now, for you to use a module, the first thing you need to do is you need to import it. And by importing, what we simply mean is that you need to bring this module in the programming workspace. Python needs to become aware that these things, these resources are now available for it to look at, and that's what basically what import is. And an import is done using an import statement. And how do we do an import? Basically, you type import, then followed by the name of the module, like this. So in this lecture, we're going to be looking at the math module, which is a common library for elementary mathematics functions, and I think it's familiar to us with physics, so that's what we're going to look at. If you want to import a variable, for example, the value of pi, you can say the name of the module followed by, then you put a dot followed by the variable you want to import. In the case of a function, if you want to import a function, once you have if you want to access a variable, then you type out the name of the module, then a dot followed by the variable. If you want to access a function from a module you've imported, then you type out the name of the module, then you put a dot followed by the name of the function. So basically, as we are going to proceed, I've said that we're going to be working with the math module, which is handy since we have to do mathematics occasionally, most of the time when we're doing physics, and it would be nice to know how to do this. So in the case here, so I'll start out with trying to import the math module. So basically, how do I do that? I simply type import followed by the name of the module, which is math, and I click on run. So the import statement has worked. Next, once you've imported a module, you can print out a list of the contents of that module. What does this module have? So that's what I'm going to do here. So I'm going to use this function, dir, to access the items which are in this module, which I've imported. And I'll do a printout there. So when I do that, basically what you get is a list of all these things which are in the math module. You will see there is pi here, which is of interest to us. There is square root here. So pi is a value, square root is a function. You've got sine, you've got tangent. What else do you have? You've got log 10. You have some value here, not a number. There is the function, the gamma function. You've got exponential. There is factorial here. There is a flow function here. There is a cosine function there. There is a function called degrees. There is Euler's number here, E. So basically, that operation there, once you import a function, you are able to see what you have imported. If you need more explanation on what each of these things are doing, so in that particular case, then you can ask for help. You say help math. When you run that command there, then you're going to get a description, a help file on each of those things. So in this particular case, this says spell out the name of the module, which is math here. Then you have some documentation and the description of the module here. It says this module provides access to mathematical functions defined by the C standard. And next comes a list of the functions arranged alphabetically starting from A up to Z, if those functions are there. So as you can see, you have arc cosine. Then there's an explanation of what the function does. Returns the arc cosine here. Then what else? There you have got this one, the ceiling function returns the ceiling of x as an integral. Then what other function could you use? The cosine function returns the cosine of x measured in radians. There's this other one, degrees, converts angle x from radians to degrees. Then this one is a distance. So if you've got a point, x and y coordinates, using this function, it can work out the distance between 2 points in Euclidean space. Then there's here the expo function returns e raised to the power of x. Then this one here, x power m minus 1, m1, returns the exponent of x minus 1. Then there's factorial here, find x factorial, then flow, and basically that's basically how it goes. So basically that's if you want an explanation of what these functions you have imported, which are in the module are. Nearly at the end also, you will find data. So basically these are constants which are being used in this particular module. So in the math function, the math module comes with functions. It also comes with a bit of data. For example, or some of the data you might be interested in is Euler's number here, and also of interest to us will be the value of pi. So you don't have to actually type out the value of pi up to that precision. You can just simply import it and start using it like that. So basically that's how you read the help file of any module you have imported using the help function. Okay, now how do we access, for example, pi in this particular case? For you to access the value of pi, which is this one here, you need to start out with the name of the module, which is math, then you put a dot, then followed by the value you want to access, which is pi. If you do that, yes.
What is the meaning of is it integer or what? It's just the numbering?
Where?
In front.
Input.
Oh, that's input.
That's input. This is output.
Okay. So
Yeah.
pi is a double or fourth number.
Yes, yes,
Don't
yes.
you need to declare somewhere?
No, you don't have to declare. Python already knows that it's,
Okay.
yeah. So with Python, you don't have to declare the data types of all these things.
Okay, right.
Yeah. So there, you access your pi value. If
So you're going to state the number of decimal places you want.
it has, you can, there's a way of stating the number of decimal places you have, but we already looked at that previously. Yes. If you try to access pi without including the name of the module, then like in this case, then you try to access pi, then Python is going to say pi is not defined. The reason why it's saying this is because there's places where Python looks for this information. But in the other case here, you have told Python to look in this module, then find this particular value. So Python just looked in the usual places, it didn't find it. So you have to state, it's important that you state the module where this particular information is, data is. Here you can also access the value for Euler's number, math.e, that's there. Then here, the SQR. If you're a suspicion, say this is square root, then you can ask for help. Also, you can say the name of the module, then you put a dot, then the name of the function. When you do that, then you get the name of the function there, then you get an explanation of what the function does. Basically, it says returns the square root of x. So you can also get help on not everything, but you can get help on specific functions which you are interested in using. So basically, that's how you do it. You say help, then you start with the name of the module, you put a dot, then the name of the function. You can also do the same thing with variables, I think. So in this particular case, if you want to work out the square root of 25, you would say math.square root, then in the parentheses here, you put the argument or the value whose square root you want to work out, which is 25. When you do that, you're going to get your 5.0 like that. If you try to work out this square root without including the name of the module, like in this case, square root 25, when you try to do that, Python will tell you, I haven't found square root. So like in that case, again, the same problem we had with pi, it looked in the usual places, it didn't find anything, so it tells you, I haven't found anything. So you need to tell it, say, I want you to look in this particular location, look in this particular file, find the function called square root, then use that. So basically, the same thing. Here also, there's a function called power, which you can use to raise a particular value to a particular power if that's what you want. So you can ask for help on math.power, like that. So here, you get an explanation, say returns x raised to the power y. This is something you can do manually. We know how to do this, but if you want to use a function, then you can use that. So in this particular case, you say math.power 5 raised to the power 3. If you do that, you get your 125. So basically, once you import a module into the workspace, then you want to access either the data or the functions which are in that particular module. You need to start out with the name of the module, then you put a dot, then the data you want to access or the function you want to access, like that. Okay, any questions so far?
On this power, isn't that a repetition?
Of?
When I say power of, compare the power of 5 raised to the power 3.
Yeah, that's 5 raised to the power of the 5 is
the power of 5 raised to the 5 raised to the power 3.
Yeah, 5 raised to the power 3. That's what it's doing.
Oh, But I'm talking about the writing there.
Oh, okay. Oh, yeah. Okay. Oh, great. Okay, thank you for that. Okay. Now, if on the other hand, clearly you can see that this whole business of including the module, then you put a dot, then the function can become a bit more tedious, especially if the name of the module is long. If the module name is long, then this thing of name of module dot whatever it is variable name of module dot function starts to become a bit more tedious. So there's a way around that where you can actually import specific variables or data from a module. And how you go about doing that is you start with from the name of the module, then import, then you list what kind of variables or data you want to import in that particular case. This is if you want to import only one. If you want to import multiple variables or multiple data, so you can say from module import variable 1, then comma variable 2, comma variable 3, like that. So that allows you to access multiple data from that particular thing. So in this particular case, we want to import pi from the math module so that we don't have to say math.pi. We just want to say pi. Then Python should know that basically this is what you've done. So we're going to say from the name of the module, which is math, import pi. When you run this statement, that it runs. Now we can print out pi. Remember when you just printed out pi previously, it failed. Now it will become possible for us to print out pi. When I print out pi, now it's going to give me the value which is in the file. So basically this is how you can import a specific data from a module so that you don't have to include the name of the module. You can also import multiple variables at the same time. For example, here I want to import Euler's number and I also want to import tau. So I can say from math import E, which is Euler's number, and tau, like that. So you separate the things you're importing by commas, like that. So now I can say, remember we have not defined E anywhere as we started. So I print out E. Now it gives you the value of Euler's number. I can print out tau and you get that. So basically this is how you can access specific data from a variable. So it depends on what you're doing. If there's an E, is there a pi, is there, then you can import those things, then you bring them in the current working space. You can also do the same thing for functions. You can import specific functions, a single function, or you can import multiple functions. So if you're only importing one function, you say from module import the name of the function, like that. Or if you are interested in importing more than one function, then you can say from module import function 1, then comma function 2, then comma function 3, like that. So in this particular case, I want to import the remainder function. So if you are trying to work out the remainder of a particular operation, when we started out, we had worked out the remainder mechanically, but there's actually a function which does that in this module. So you can say from math import remainder. When you do that, then once you have imported remainder, now you can ask for help by simply typing help remainder. You don't have to include the math.remainder anymore, because now you have imported this specific function. When you ask for help on this remainder function, then the help description says difference between x and y and the closest integer. Basically it tries to explain what the remainder thing does. So in this particular case, if I'm looking for the remainder of 10 divided by 3, so I say remainder, give out the first value, which is 10. I'm dividing by 3. The remainder of this operation now is going to be 1, like that. So now I can use that particular function for that particular purpose. If I want to import more than one function, for example, I want to import factorial, I want to import the ceiling function, I also want to import the floor function, I'll say from math import factorial, then comma ceiling and floor. So I can import these 3 functions at once. When I do that, then like that, then I ask for help on how to use factorial. What does factorial do? Basically it says it finds x factorial, like that. So how, if I do that, so for me to find the factorial of 5, I say factorial 5, then it gives me 120. For the ceiling function itself, if I ask for help, what does the ceiling do? Basically retains the ceiling of x as an integer. Basically, ceiling retains whatever value you give it, takes it up to the next nearest integer, and the floor takes the value to the next nearest integer. So in this particular case, for 4.7, the ceiling of 4.7 is going to be 5, and for floor, ask for help on what floor does. So basically, this is the largest integer, less than x. So the floor for 4.7 in this particular case is 4. So basically, this is how you carry out these import operations. You can import a single function from a module. You don't have to, or you can import specific functions, then you start using them on that. Any questions so far on how you import specific variables or specific functions from a module? This whole operation you're doing here applies to all modules in Python. So this is like, we're looking specifically at the math module, but you can do this, follow these same steps for any module you have in Python. You can also import, yes?
So suppose before you record, like, for example, here, after importing, before you import it, you define it. Say E is a certain number, say 2. Okay, then you call it now after importing. Is it going to overwrite or what's going to happen?
My suspicion is that it's going to overwrite or it might not. So basically, there's going to be a conflict in the naming thing. And that's what the next part is trying to address.
The other thing, Mr. Sean, since this is in math mode, this is already defined in there.
Yes.
So
suppose you're saying, suppose you defined E before you imported.
Yeah, there will be a conflict.
Yeah, there's going to be a conflict, or most likely there's going to be an overwriting which is going to happen, because Python itself does not have the concept of constants. Some programming languages have got a concept of where you can define a constant which cannot be changed. But for Python, basically everything is variables. So if everything comes in as variable, then it can be overwritten. So there's a possibility that it can be overwritten. Apart from just the naming conflict, there is also a dangerous possibility that something can be overwritten.
But when it is overwritten, what is the implication subsequently?
It means that the value which was there previously is going to be erased. A new value, a new value is going to be put in.
Like these functions are already default functions.
Yeah.
So
Maybe
it
like
you cannot interfere in this because they are already defined in there. But supposing you define like Dr. Marama said.
Yeah, we can always try. For example, we can say E. Let's try E or pi. Pi, we give it value of what? 10.
Oh, 10, yeah.
Then, okay. Now if we say pi, print pi. Now it's going to be 10. It's no longer there. So it overrides.
But my worry is what's going to happen subsequently. For example, sin x, sin 30 is 0.5. Suppose I find something else. Will it stick to my calculator what I've defined?
It will stick to what you define.
It sticks to what you have defined.
Yeah, because that's the value that you need.
That's the most recent value which it has.
Because if you define the something and then somebody else wants to use it, he knows it.
So in the case of modules, like the way they come here, the ones which come with Python, you are shown what the values are and what the function does, but the implementation you're not allowed to modify it. So how the function works, you're not allowed to change how the function works. You're only given access to what the function does and the explanations of how to use the function. So there's a way, that's a way around trying to stop people from changing things they're not supposed to change. But when you create your own modules, then you give it to someone, that particular someone can go and change it. Because you've given them everything. You've given them the source code for all the functions.
You have encapsulation and inheritance.
You have what?
You can hide data, right? Data
Yes. That the data hiding is there, yes. Okay, so you can also, if you already have, like you said, if you already have something which you've already defined, so you're trying to avoid this conflict of overwriting, or maybe the name of the function is too long, like remainder, the way it was, or something else, you can import that particular function using an alias. which you can make to be very short. So in this particular case, you'd say from the module, import function as alias. So you change the name of the function, you give it a new name. Not necessarily that the actual name of the function in the file, in the module is being changed, but in the workspace where you're importing it, you give it a new name, you give it a nickname. For example, remember we have the function radians, which changes degrees to radians. But if you think typing radians out like this is too much, then you can give radians, the function radians, a nickname rad, like this. So you can say, from math, import radians as rad. So going forward, after you've done this import, where rad is now the alias of radians, now you can ask for help on rad. You can say help rad instead of typing radians. Then this nickname is going to, Python is going to go straight to this, which is the same, which is now the nickname of the actual function, and read out for you what the function radian does. Then when you try to use going forward, if you're trying to use the function radians, you simply say rad 180 degrees. So this is basically us changing 180 degrees into radians, and you get your value of pi like that. So this is one way of avoiding naming conflicts in the programming workspace.
So just a quick one.
Yes.
So even though we have done an alias rad, can we still use radians itself? Maybe try it.
It will not work.
Oh.
I don't think it will work. Let me see. Radians 180. There, it refuses. Name radians not defined. Yeah. So it will not work.
But I think if when you finally you exit from your working, the whole thing returns back.
When you close when you close the workspace, all the data is lost. The ones you imported.
No, the ones you imported.
But the because this module is actually a file, the data in the module stays on the hard drive. So next time again when you run your programs, it will load up these things. So the ones you have imported in the workspace, they will be lost. Yes.
But this is like on a terminal, right? You just open it on the terminal.
Yeah, you just open. Just open. Yeah.
Program, right? And everything. And all stuff.
After that. Also, there is a function called degrees. Again, this is too much typing. So if you are not interested in too much typing, then you can give this function degrees. You can give it alias this, like that. So you can say from math import degrees as deg like that. Then you can now ask for help on deg like that. So it will point you to degrees. Then it says convert angle x from radians into degrees. Now the problem here is the value of pi. Remember we overwrote it. We gave it a value of 10. So I need to go back a bit and just make a new import of pi here. Run that. Then okay, now it's good. So now I can use the imported value of pi. So print pi. So that's the value of pi we have. So I can change this value of pi from radians to degrees like that. Now I get 180 degrees. Okay. You can also import a whole module. If the name of the module is too much, you can give the name of the module an alias. So in that particular case, you can say import module as alias. So in the case of, if you find it very frustrating to type too much typing, to type math like this, you can give the math module an alias m like this. So going forward, you say import math as m. So you can just give it an alias of 1 letter, or usually most of the aliases is 1 letter or 2 letters or 3 letters. Then after that, it's too much, like that. So with this, now I can say m.pi, which is just basically short for math.pi, like that. I can say m.e, like that, or I can say m.square root, which gives me that bit there. Okay, any questions? This bit here, importing every variable and function in a module using the asterisk, this bit here is dangerous because you might have defined certain functions and certain variables in your current workspace. When you import everything, then of course, as we have seen, there's going to be overwriting. So if there is a variable which has the same name as what you're currently importing, then there'll be overwriting and stuff like that. So as much as you can do this, fine, like this. So how do you do this? You say from module, import, then you put a star like that. So this bit here is going to give you access to everything which is in a particular module. But it's not encouraged. It's better you just pick what you need. Go for specifics. You pick the kind of data you need, or you pick the functions which you need from that particular bit. So when you do this from math import star like that, then now you can do the radians. You can say radians 180 because now you have imported everything. Every function in the math, you now have access to it. You now have access to the data. Now you can say radians, which didn't work, 180 degrees like that. You can say degrees like that. You can say cosine pi like this. Now you have access to that. Okay, so this is you are using a built-in module. Okay, but it's possible for you to create your own modules also, and that's basically the next bit which I am going to show. How do you create your own modules? Now, for you to create your own module, what you need is a text file. You need to have a text file, and this text file you can create it with any text editor. Then that text file, the name of the module, so you need to have the name of the module, and it needs to end with an extension .py. And I'm going to show what I have in this particular case. So I've got two modules. I'll click that, and I have this one. So we'll start with the first one. So this one, as you can see, the name of the text file is physical constants. So physical underscore constants.py. So if the module name has got two words, then you connect them using an underscore like that. So the first thing you do when you are creating a Python module is you need this line here. This is the line which explains the description of the module, which gives a description of what the module does. And this line has to be in triple quotation marks, like this. So you have to start with quotation marks like that, 3 quotation marks. You have to end with 3 quotation marks. This is what is referred to as triple quotation marks. After that, what kind of data what kind of constants am I defining in this particular case? You can see speed of light, I give it that value. Gravitational constant, I give it this value. Planck's constant, I give it that value. Of course, after that, there's some comments I've put there. This is speed of light, symbol is C units, whatever it is. Gravitational constant, Planck's constant like that. Electron charge, I give you that value. Electron charge, symbol E, that bit. Permittivity constant, that. Permeability constant, Avogadro's constant, Boltzmann's constant, the gas constant, Stefan Boltzmann's constant, Wien displacement constant, atomic mass, electron mass, proton mass, neutron mass, standard gravitational acceleration, atmospheric pressure, standard atmosphere, Hubble's constant, Earth mass, Earth radius, density, density, Earth moon distance, Earth sun distance, mass like that. So basically, this is a module with some physical constants which we use in physics. So for this module, you can either ask me or you can create your own, but I wouldn't encourage you to create your own because I already have some things. The only thing you should do is probably say, I'm asking for that particular file, then you go and add your other things so that we extend how much of this thing we have like that. So basically, that's what a module is in a nutshell. Simply a text file with a name, it ends with .py. Then here you start out with this triple quotation mark line, which gives a description of what the module does and whatever values you have defined inside there. And of course, then you can save it. It needs to be saved. Then you need to put this particular module or constant in the same location as a file. So how am I going to use this thing? As you can see, it's 2 words. It's physical constants, which is too much for me to type already. So I don't want to go around typing physical constants. So instead, what I'm going to do is I'm going to import this particular module using an alias, which I'm going to call PC. So import physical constants using alias PCs, I'll say. So import physical constants as PC. So when I do that, okay, then now I can print out the contents of this particular PC, and this basically, if you see it here, I get a list of all those items which are in that module without their values. So basically, in this particular case, the values of the constants have been hidden from you. That's what Dr. Mlilo was trying to say. Is there a way in which you can hide data? So basically, that's what you have there. So if I need help, in this particular case, then now I can see the values. So it says data here, then you can see all the values with the constants like that, arranged alphabetically. So if you look at what I had, it wasn't alphabetical, but the data, once you ask for help, your constants are going to be displayed alphabetically like that. Then at the bottom here, you're going to find the file where the particular data is. So if I want to now access Avogadro's constant, I can say pc.avogadro's constant. I'll get that. If I want to access electron charge, I'll say pc.electron charge. I'll get that. If I want to access proton mass, I'll say pc.proton mass. I'll get that. If I want to access Hubble's constant, I'll say pc.Hubble's constant. I'll get that. Like that. So I can access the data like that. If I don't want to use the alias PC, I can simply import the specific variables again. I can say from physical constants, import neutron mass, like that. So once I do that, now I can just simply print out neutron mass and I'm going to get that. Or I can say, import the mass of the sun, Planck's constant, electron mass. I can say from physical constants, import sun mass, Planck's constant, and electron masses. Once I do that, now I can print out the sun of the mass. I can print out Planck's constant. I can print out electron mass like that. Then, so that's if you don't want to include the alias. You can simply import all these specific values like that. However, we also know that some of these constants I've defined have got specific symbols which you use in physics. For example, the speed of light. So you might import the speed of light using the alias c. So for example, I was saying from physical constants, import speed of light as c. So when I do this, now I can simply print out c. When I print out c, then it prints out the value of speed of light like this. So this is us using aliases for specific values like that. Also, electron charge, you know that electron charge has got we use the symbol E. So I can say from physical constants, import electron charge as E, like that. So if I do that, then I print out E, then it gives me the value of the electron charge. And also, there's the gas constant. I can say from physical constants, import gas constant as R. So if I do that, then now I have the gas constant like that. And of course, this other one here, Stefan Boltzmann's constant. If I want to import this one, say from physical constants, import Boltzmann's constant as K, like that. So if I do that, then I get that. Then of course, there is the last one here. There is acceleration due to gravity. Of course, as you can see, the way I defined it there was basically it's made of 3 names, like that. But I can use the alias G like that. Then if I do that, then that's how I get my thing here, acceleration due to gravity. So basically, it's possible for you to create a module where you have all these, depending on your field, you create a file, computer file, with all the constants you need. Then you move from there. You can also have a module which contains actual functions. Like in this particular case, I have created a simple module which contains 4 functions called projectiles, as you are going to see. If I import this particular, say import projectiles there, then I print out the contents of these projectiles. It actually has a function which works out the flight time of a projectile, which works out the maximum height reached by a projectile, which works out the projectile range, and also which works out how much time it takes a projectile to reach maximum height, rise time. Then, if I ask for help on this projectile function, basically, this is what you get. So basically, these are the things look like. The functions: flight time, it needs velocity and angle, retains the flight time of a projectile. Maximum height, velocity and angle, retains maximum height reached by a projectile. Projectile range, retains the horizontal range reached by a projectile. Then retain the rise time of projectile. This is rise time. How does the actual file look like? Here it is. Again, as you can see, it's simply a text file with an appropriate name, which is projectile. Then it ends with .py. Then again here, first line in triple quotation marks. It's a description of what that particular module is doing. So in this particular case, this module calculates the rise time, flight time, maximum height, and range of a projectile under gravity. So I start out with the first function. We saw how to create functions the last time we presented. We were talking about functions. So you start out with define here, DEF. Then next comes the name of the function I'm trying to create, which is rise time. It's going to need the velocity. I'm going to need the angle. Then I end with semicolons there. Then inside the function again, this same triple quotation mark system comes in. This now I'm going to use to describe what the function does. So in this particular case, I say it retains the rise time of a projectile to maximum height. Now I start the process I've been doing up there. Now for me to work out this, I need G, which is gravitational constant. So I say from physical constants, import standard gravitational acceleration as G. Then I also need sine and radians. From math, import sine and radians. The reason why I need radians is because the computer does not work out angles using degrees. It works out angles using radians. So whatever angle I'm going to get in degrees, I need to change it into radians, then proceed from there. So the first thing I do is, with my radians function imported, I give it the angle which we're going to put there, and I change this angle into radians, and I store it as theta. Then I work out the rise time using this particular formula, velocity times sine of theta divided by G, like that. Then after finding the rising time, I retain the rising time as a rise time. I'm doing the similar thing for the flight time here, except for flight time, I need to multiply by 2 there. Then I retain the flying time. Then maximum height again. Basically, it's just me translating the formulas we have for projectile motion into the equivalent things following the Python thing, like that. Then this one is for the range, also like that. So basically, as you can see, it's simply the same stuff which we have been doing, like that. So with this file in place, like that, now I can move, since I've already imported that bit. Where am I? Here. Now what I want to do here, I don't want to include, because projectile again is too many words. So I don't want to include the projectile in the thing. So basically I say, okay, fine, let me just import the specific functions which I need. So in this particular case, I say from projectile, import rise time and flight time. So that's the first import that gives me access to the rise time and flight time. Again, I say from projectile, import maximum height and projectile range, like that. Now here, the problem I'm trying to work out is, I've got this particular problem, a towed artillery gun with a muzzle velocity of 550 meters per second fires a high explosive shell at an angle of 45 degrees. Calculate the rise time, flight time, maximum height, and range of projectile. So in this particular case, since I've already imported these things, I simply call this rise time function. I give it the velocity, 550. I give it the angle, 45. Whatever the answer is, then I print out in this particular format, as you're going to see. Then here I'm doing the same thing. For the flight time, I give it the velocity, the angle, whatever the answer is, I'm printing out here. Same for the maximum height, same for the projectile thing. So when I run this particular code, what I get is this. The rise time will be 39.7, flight time will be 79.3, maximum height reach will be 7,711, and the range is going to be somewhere 30.8 meters of the projectile. Then of course I repeat the same problem, but now the angle is at 90 degrees. So I'm basically trying to check if things make sense. So when I do this, again, so here you see that rise time increases because now it's 90 degrees, but the range is going to be 0 because the thing just comes back wherever it is. So basically, that's how you can access modules, and also that's how you can create your own modules like this. Yes?
Yes, maybe I switched off when you spoke about this. Suppose you are importing several functions. You're importing several functions and you want to import them as alias.
So if you're using an alias, if you're using an alias, you can only use an alias for one function. Yes. Otherwise, if you're not using aliases, then you can import several functions like that. But for alias, it has to be one. Okay. So we have come to the end. So today I don't have to ask for extra time. So any questions? So we have reached the end of this introduction to modules. So there is a lot of possibility because first years we have got formulas, second years there's formulas, third year, yeah. So hopefully in future, as much as We know for physics, mathematics is fundamental. It's basically the bedrock of physics. Right now, I think also there's a lot of change where people are using computers a lot to do physics. It makes things faster. It makes our research move faster, and you can quickly see whether things are working or not. So hopefully, computation and computer programming will become not just a course at third year and fourth year, but we can start the way mathematics starts at first year, second year. Always each year at least someone is taking a computer course until they reach fourth year, so that we have these whole two things which we need. And it's also good for the country, I think, when you've got people who have got mathematics, who know computers, who can translate mathematics into computers. That's good for our technology industry.
Yeah,
Yes.
Just a comment also. I'm also thinking that even our labs, we can look at simulating some of them.
Yeah.
Of course, maybe on the internet we can find simulations, but with these tools, we can try to build simulations for whatever we do in our
Yes,
in our labs.
that's all.
So,
That's all
so
part
what
of it.
could happen in the beginning maybe is for specific experiments, maybe in our fourth year or master's students, they can pick up those experiments to put them into simulation mode as a project.
That's what Mishek Lungu is doing. So Professor Jain, for what's this, renewable energy physics, Professor Jain has selected certain experiments he thinks are better done using computers, so that we can see if we can produce computer codes which are going to be used for this particular thing. For example, the black body radiation cave experiments. So we are working on that with Mishek, so that certain things can come out as students are running these computer codes. They can see how the plots are coming out. They can see how the caves are shifting and stuff like that as the temperature increases, and whether certain things, for example, there are certain approximating formulas like what is that? The one we're looking at, Wien's law, which approximates the maximum, the peak wavelength, and also Stefan's the one which gives you the maximum power under the cave. So there's certain approximating formulas. So basically, we can use those to show that these approximations work as good as the exact thing. So, and that can only be done through using computers and looking at what the results are.
Yeah, so the thing is, COVID has shown us that sometimes we may not need to be here physically.
Yeah, because there'll be a time when it will be difficult to do labs physically. So if it's difficult to do labs physically, can those labs be done electronically? So that could be a project for a fourth year student to actually say, we're giving you this lab, can you do this? Of course, there'll be other things which need to be added, because right now at the stage where we are, this is just text, but they also have to be visuals. So how do we do that? So basically, it to be a work in progress thing where you're constantly improving on something. If the new tools come up where you can actually, people can see things moving visually, then based on the physics which is happening behind, then
then maybe lastly, I know you are using Linux, but maybe it would have been nice to show how you can use Word, Microsoft Word, to write any text file.
Oh, you can't use Microsoft Word because Microsoft Word is it's a word processor, it's not a text editor.
Oh, so which one can work? Not?
Yes, Notepad or WordPad.
Okay.
Yeah.
So I hope that clears for.
So if you're trying to create a module, then you have to use a text editor. Word processors are different from. Basically, they are simple things.
Sure. So I mentioned this because you like using Jupyter Notebook, and there are several others that people can use for Python.
Yeah, Jupyter Notebook also works for Windows, so you don't have to. As much as I use Linux, once you install Jupyter Notebook, you have access to the same functionality as I have. Yes. Yeah, so it's a cross-platform to whether you're using Mac or you're using Linux or you're using Windows. Same. And that's also part of the reason why we chose Python, because Python is a cross-platform language. So you don't have, you can still keep your computer
Mm.
and continue to do the things you're doing.
Okay, thank you very much. Then maybe just before we disappear, I see all of us here have an interest in physics. We are trying to register the Physics Society of Zambia under the Registrar of Societies, but we are somehow struggling financially. We need 6,200. We had raised about 5,000.
Yeah.
We used some of the money for
registration.
activities, but currently we have 3,200. So we need 3,000 kwacha or a bit more to allow us to pay and lodge in the documents that we have at the Registrar of Societies. So a number of us have contributed, but we are asking everyone, especially maybe members of staff. A number of us have already given, Dr. Rajan, myself, Dr. Mdenda, I'm not sure who else, but for those who have